Hello everyone. This unit demonstrates the evaluation of definite integrals, including the application of Wallis formula. The definite integral of f of x between the limits x is equal to a and x is equal to b is f of x. In symbols, if we take the integral from a to b of f of x dx, this is equal to a function of x from limits a up to b. If we evaluate the limit, we take the function of the upper limit b minus the function of the lower limit a. This change in the value of the integral between two values of the variable is required in many important problems. It is called the definite integral because its value is independent of the constant of integration. The integral from 4 to 5 of the quantity 32v minus 20 dv is 16v squared minus 20v with limits from 4 to 5. We evaluate this by taking the function of 5 minus the function of 4. The function of 5 is 16 times 5 squared minus 20 times 5. The function of 4 is minus the quantity 16 times 4 squared minus 20 times 4. We get 300 minus 176 with an answer of 124. The integral from 0 to 1 of the quantity t plus 1 raised to 5 dt is equal to the quantity t plus 1 raised to 6 over 6 with limits from 0 to 1. Evaluating, we get 64 over 6 minus 1 over 6. Simplifying, we get 63 over 6, which is equivalent to 21 over 2. The integral from negative 2 to 2 of x squared times the quantity x plus 2 dx could be written as the integral from negative 2 to 2 of the quantity x cubed plus 2x squared times dx. Integrating, we get x raised to 4 over 4 plus 2x cubed over 3 with limits from negative 2 to 2. Evaluating, we get an answer of 32 over 3. If we take the integral from 0 to pi of cosine theta over 2 d theta, this will be equal to 2 sine of theta over 2 with limits from 0 to pi. We evaluate this by taking the function of pi minus the function of 0. The function of pi is 2 sine pi over 2 and the function of 0 is minus 2 sine of 0 over 2. We know that the sine of pi over 2 is 1 and the sine of 0 is 0. So we get 2 times 1 minus 2 times 0 with a final answer of 2. The Wallis formula tells us that if we take the integral from 0 to pi over 2 of sine raised to m x times cosine raised to n times x dx, this is equal to m minus 1 times m minus 3 until 2 or 1 is reached. We multiply this by n minus 1 times n minus 3 until 2 or 1 is reached, divided by m plus n times m plus n minus 2 until 2 or 1 is reached, and we multiply alpha. Take note that for the Wallis formula, the m and the n are integers that must be greater or equal to 0. Alpha is equal to pi over 2 if m and n are both even. Alpha is 1 if either 1 or both are odd. And the Wallis formula is only used when the lower and the upper limits are 0 and pi over 2. The integral of sine raised to 10x dx from 0 to pi over 2 tells us that m is equal to 10 and n is equal to 0. Applying the Wallis formula, the numerator will be m minus 1 times m minus 3 times m minus 5 times m minus 7 and m minus 9. The denominator's factors will be m times m minus 2 times m minus 4 times m minus 6 times m minus 8, and we multiply the alpha. If we substitute the values using the Wallis formula, m minus 1 is 9, m minus 3 is 7, m minus 5 is 5, m minus 7 is 3, and m minus 9 is 1. For the denominator, m is 10, m minus 2 is 8, m minus 4 is 6, m minus 6 is 4, and m minus 8 is 2. The alpha will be pi over 2 since 10 is an even number. If we multiply the factors of the numerator and the denominator, we get 945 pi all over 7,680. Reducing it to its lowest term will be giving us the answer, which is 63 pi all over 512. The integral from 0 to pi over 2 of cosine raised to 8x dx is equal to 7. 7 is taken from 8 minus 1, where 8 is n, which is the exponent of cosine x. So it follows 7 will be multiplied by 5, multiplied by 3, and multiplied by 1, all over 8. 8 multiplied by 6, multiplied by 4, and multiplied by 2. We multiply alpha, which is equivalent to pi over 2, since 8 is even. And our answer will be 35 pi all over 256. If we take the integral from 0 to pi over 2 of cosine raised to 5x times sine squared x dx, if we apply the Wallis formula, the first term on the numerator is 4. 4 is taken from the exponent cosine, which is 5. So 5 minus 1 is 4. And it follows 4 will be multiplied by 2. For the exponent of sine, which is 2, if we subtract 1, it becomes 1. So we multiply 1. The denominator will be the sum of the exponents of sine and cosine, which is 7. 7 is taken from the sum of 5 and 2. So the denominator becomes 7 times 5 times 3 times 1. Since 1 is odd, which is 5, we just multiply 1, and our final answer becomes 8 all over 105.